So now that you guys have seen some Lewis symbols and some Lewis structures, let's actually talk about the procedure that you want to use when you're actually drawing these Lewis structures. So the first thing you want to do is find the sum of all the valence electrons of all atoms in that polyatomic ion or molecule. So Lewis structures are specifically for drawing molecules or polyatomic ions. And notice that if it's an anion, you need to add to that sum of the valence electrons, add one electron. If it's a cation, you subtract one electron from that sum. Then you want to figure out where to place all those element symbols. So you want, of course, an element symbol for each atom or in that molecule or ion. You want to put in the center the least electronegative element that isn't hydrogen. Now the reason why you don't want hydrogen in the center is because, as you'll find out soon, hydrogen can only ever have a single bond, okay? Now you connect the outer atoms by single bonds. Remember, the single bonds are represented by the single lines, and those are representing 2 electrons. The next step is to fill out the octets of the outer atoms. That is, to add enough lone pair electrons that all of the outside atoms only, not the central atom, have a set of 8 electrons, including the ones involved in bonding. Finally, you fill out the octet of the central atom, and then you do a check of how many electrons you used. If you ended up having fewer electrons, okay, so if you ended up using fewer electrons than what you're supposed to use, we'll talk about that in a little bit. But if you end up using too many electrons, you need to form some number of multiple bonds. Enough double bonds that you will be able to have the correct number of electrons in your Lewis structure. First off, find the total number of electrons. For phosphorus and chlorine, valence electrons. Okay? So for phosphorus and chlorine, if we look over at the periodic, we see phosphorus is here in the 5A. That means it's got 5 valence electrons. Chlorine is in 7A. It's got 7 valence electrons. So back to our calculation. We have 1 phosphorus, so 5 times 1 is 5. And then we have 3 chlorines in our formula. So we need to take the total number of valence electrons for chlorine, multiply it by 3. So 5 plus 3 times 7, 21, should be 26 valence electrons. Next step is put the least electronegative atom in the center and make a single bond to it. Looking back at the periodic table, we see that phosphorus is here, chlorine is over here. Remember, electronegativity goes up to the upper right hand side, so it increases like this. And so phosphorus should be less electronegative than chlorine. So back here we put phosphorus in the center, chlorines are surrounding it, Cl, 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 and single bonds to each of those. At this point, it's a good idea to do an electron check to see how many we use. We have 26 electrons that we can use total from over here. So far we used 2, 4, 6, so minus 6, so we have 20 electrons left. Next step, we want to fill the outer octets. So notice chlorine's missing electrons here, so phosphorus, chlorine, chlorine, chlorine. Then we're going to fill these outer octets. Notice now what we have is chlorines with 8 electrons around each one of those guys. 2, 4, 6, 8, all the way around. Now we've added 6 electrons here, 6 here, 6 here, so we had 20 electrons left over. Minus 18, 6 times 3 is 18, so we have 2 electrons left. Finally, we want to fill the octet of the central atom, so phosphorus, dot, dot, chlorine, dot, 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 chlorine, dot, 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 dot. Yes, it's a lot of repetition. And, alright. We have these final two ones. We end up with 0 electrons left over. We had 2 from that last step. We now have 0. And so this is our Lewis structure for phosphorus trichloride.